Right. So in today's class, we will be seeing about a sensor and how a sensor is being classified. We already have seen called as sensors, and in this class, we'll be seeing like how a sensor is being classified. Right. So before getting into that, by the end of the last class, I gave you a small task like find the measurement system. I mean the instrument system behind a fingerprint sensor. I don't know how many of you have did it. So I'll go back to that particular slide once again. Okay, so this is a generalized measurement system or an instrumentation system. In this, if you see, we have 5 blocks. One is data, sensing element, then data manipulation, processing, transmission, and output. Right? We saw all this thing being employed in a camera sensor. Right? So we saw in camera, the sensor is the first part which converts the light into electrical signal, and the second part manipulation is where the analog signal is being converted into digital form, and processing is where your digital zeros and ones gets converted into your image, and the fourth stage is that the converted image is being transmitted to the internal storage or your memory card or whatever it is available, and fifth is the displaying of output. Right, so we are going to see that file in fingerprint sensor. Okay, so I don't know how many of you have thought about it, but anyway, given the answer, so see it. Like if you take a fingerprint sensor, what happens is that we keep our finger on the sensor, right? So that sensor, that first part is your first block, sensor, which senses your fingerprint, right? Then what happens is that that fingerprint that is being sensed is actually in analog form. Okay, hope you know the difference between an analog signal and digital signal. Analog is continuous, digital is discrete, or just zeros and ones, something like that, right? So what happens is that when you keep your finger on a fingerprint sensor, that fingerprint is actually taken by the sensor as analog input, and that analog input will be given to the next phase, which is this part, right? So in that phase, what happens is the analog signal gets converted into digital form, right? So this digital signal is what is sent to the processor. Okay, so processor, what here the processor does is that it compares the fingerprint with the already registered fingerprint. Okay, so if already registered fingerprint is same as what we got here, then what will happen, that information will go to the next block, that is transmitted to the next block, and the screen will unlock only if the fingerprint is valid. If the fingerprint is not valid, then again another information will go to the screen saying that the fingerprint is not valid, right? So this is how the fingerprint system works. Okay, basic is the sensor. Okay, so in this particular class we will be only seeing about, like in this particular subject we will be dealing mostly with this sensors. In the subjects in the next semesters you will be learning about system, right? Okay, now we will move to the next one. Since we all be we have just got introduced ourselves to fingerprint sensor, I would like to tell you what are all the different fingerprint sensors that are available in the current scenario. Okay, so first one is optical sensor, then capacitive sensor, ultrasonic sensor. Okay, now tell me, what kind of sensor are we using in your mobile phones? It's quite obvious. Anyway, if you think we are using optical sensors, enter number 1 in your chat box. If you think you are using capacitive, enter 2. If you think you are using ultrasonic, enter number 3. Okay, the answer is quite obvious. Every one of you can guess it. Yes, of course. Thank you. So from the images of you would have guessed. Thank you, people. Thank you, everyone. We are using capacitive scanners. Okay, any idea where we can see this optical scanners? Optical scanners. Have you any idea like where you have seen this kind of sensors? Optical scanners. Would so now from now on, now that you're learning sensors and measurement, I want you all to look everything with this perspective, like in the sensors. Okay, so got a couple of answers from Janani and Gokul. Gokul Kannan. Janani says iPhones. Okay. Gokul Kannan says face unlock. Okay, people. See, now we are talking about scans. Okay, here we are actually talking about fingerprint scanners. I'm sorry, it's my mistake. I should have mentioned it as fingerprint. Since we are on the topic of fingerprint sensor, we are actually talking about fingerprint. Okay, so iPhones, they use optical face unlock. Yes, of course they do, but they are not fingerprint sensors. And we have got another answer from Google B who says that it's a scanners. Okay, which scanner? That's what I actually wanted to know. Okay, so for you to understand easy, I would like to say the simple application, which is like if you have been to supermarkets while billing, if you see they will use this barcode sensors, right? Most of the barcode sensors will use this kind of optical scanners. Then the most prominent one, hope you all would have got your Aadhaar cards. While taking Aadhaar cards, while registering for it, you would have kept your fingers, right? While buying a new Geo SIM, you would have kept your fingers, right? So all those fingerprint scanners were actually optical scanners. Okay, next time when you come to college, see how the faculty's attendance are being marked. Okay, they have a fingerprint sensor, a system, a biometric system, in the in every block. Okay, which will be used to scan the fingerprints of the faculty members to mark their attendance. Okay, so those uh, optical sensors. Okay, so in the next slide I will tell how these optical sensors work. Okay, so capacitor sensors, we know capacitor sensors are what we are using in our current age mobile phones. And next come ultrasonic scanners. Ultrasonic scanners are same same application. They are also fingerprint sensors, but the difference is they are based on ultrasounds. Okay, so because of this property they can be kept under your screen. Okay, so if you've seen in the new mobile phones, the flagship phones they call, like in the Samsung's flagship phone, Vivo, OnePlus phones, they don't have a separate fingerprint sensor on the sides or on the back of the mobile phone, or even in the front in the bezel, but they have this sensors, the ultrasound, like the fingerprint sensor embedded on the bottom of the mobile phone screen. Okay, so if you are more interested into this mobile phone technology, there is a YouTube channel as Jerry Rig Everything. Okay, I will put that in the chat box. If you are interested, you can go and view his videos. It's quite interesting that what he does is that he will buy all new mobile phones, and he will cut open it, and he will see what all is there inside that mobile phones. Okay, so if you see that, if you see that video, you will understand this ultrasonic scanner. Okay, so next I will try to explain how these different scanners work. Okay, optical scanners, how it works is that, so I hope you can. Okay. Okay, so see, if you see, there is a what do you say? 1 second. Right. So if you see here, there is a. Okay, now you can see, I guess. Okay, so if you see this, this is a transmitter. What happens is transmitter will send light to the fingerprint. Okay, then the light that falls on the fingerprint will get reflected, and it will go to the receiver. Right. So this is how optical scanner will work. In optical scanner, you will have light falling from source then to the water. That is what is being put here. Right. The light, you can see this LED, right? This LED light will go, it falls on the finger, and it gets reflected, and that reflected light is absorbed. From that they can track the fingerprints the same way they actually track barcodes, right? Okay, if you see this, I hope you can see this region. Sorry, this actually are your fingers. Okay, if you see your fingers, you can see there are some what do you say, in technically they call it as ridges. Okay, ridges, and is what it means is that uh, okay, ringes or the small depression kind of things in your fingers, right? So that is what is seen in this particular diagram. Okay, so based on the light that falls and getting reflected, you can measure, you can manipulate the fingerprints, right? The same way in the phone, in the fingerprints that we use in phone, we use capacitors. Okay, we use the capacitive kind of sensors. Okay, we'll be studying that in the classes to come. What happens here is that when you touch, it will be like the screen, the fingerprint sensor screen, and your finger will create a capacitor. Okay, we know capacitor is two parallel plates, right? So two parallel metal plates, or you can say as two parallel conductors. Okay, our fingerprint is a conductor. Our fingers are conductor. Human body itself is a conductor. Same way, the fingerprint sensor will also be a conductor. So if we keep our hand on it, it will create some kind of a capacitance. Okay, when you remove it, what happens in a capacitor? It charges and discharges. So based on the discharging or the electrical impulses coming out, you can track the fingerprint. Okay, so in this case, they will be using so many capacitors of very small size. Okay, we cannot see with our naked eye. We may have to use microscope or something else, right? Then the third one is ultrasonic. Okay, this is similar to optical scanners. In optical scanners, we used light, whereas in ultrasonic scanners, we are going to use waves. Okay, that is going to be the only basics or the simple difference. Okay, so this is completely outside our syllabus. Anyway, I believe this will be very useful. Maybe that way like if you have a ultrasonic fingerprint scanner in your mobile phone, you can brag about it, right? Okay, so it is necessary that you should all know all those things. Okay, right? Okay, so based on this, what do you think will be the most effective one? You've seen this three, right? Optical scanners, capacitive scanners, and ultrasonic. What do you think is going to could be the most effective one? If you think it's optical scanner, put number one. If it is capacitive, number two. If it is ultrasonic, put number three. What do you think is like a most sophisticated one, or the advanced one? No answer, sir. Number three. Thank you, Google. Okay. Okay. Thank you, people. Okay. Most of you say it's number three. I don't know why you say number three. It's actually okay. It's a new technology. It's quite, what do you say? It's effective as far as mobile phones are concerned, right? But then again, capacitive scanners are also equally effective. But the problem is, if we use capacitive scanners in mobile phone, we need to have a dedicated space. Optical sensor scanners, obviously it cannot be used in your mobile phones, but other applications, most of the other applications, we use optical scanners. Big advantage is that it's very cheap, right? Compared to the other two, it's quite cheap. Okay, so now we'll move into our class. Okay, to the ones who thinks, why on earth are we studying sensors? The simple reason, according to me, is this is where automation starts. Okay, automation actually starts here from the sensors. If you see the images from the background, everything involves some kind of a sensor. Whatever electronic gadget that you have, if you say it as a smart gadget, then it obviously should have some kind of a sensor. Okay, sensor, it is the like a basics for automation. Okay, if you need something to be automated, obviously you need a sensor, right? And we need a few more important materials, like we need processors, like what we have in your computers. We call CPU as a brain, right? So like, guys, we need processor for any automation. That is why in your mobile phones we have processor. In most of the smart gadgets will be having small processor, right? Okay, so the reason why we are studying this sensor is, as I told, it is the place where automation starts. Okay, so in hospital we need so many automation, right? Like whether it be a very small temperature checking device. See, now that because of this COVID-19, we need a temperature checking device which should check the temperature from a distance. We cannot like put the physician at the risk by making him have a contact over the patient. So what they need is a non-contact solution. So in those cases we need a sensor to sense the temperature from a distance. So that comes a sensor, right? Then let's take a wheelchair. We are not using the normal wheelchairs anymore, right? For the patients, if you need to have a little more sophistication, if you need to add some more luxury into it, we use sensors. Like if you have seen this movie Tola, you'd have seen Nagarjuna is being carried by a very special wheelchair, right? It's been operated using a joystick. So all those things actually have sensor in it, right? Okay, so this is the exact reason why we are studying sensors in biomedical engineering, right? So next we will see about the classification of sensors, how these sensors are actually classified, right? So it's actually two basic classification. One is active and passive, the another one is analog and digital, right? Active and passive, analog and digital, it's a common English word, so I don't think I'll have to explain anything there. So what I want is, I want you people to guess what it could be. Okay, anyway, I have also given a few pictures near those words that will help you understand, right? So before, passive, analog, digital, what do you think active is? You have studied basic electronics, right? Can you tell me an example for passive electronic component? Example for passive electronic component. Anyone? No idea. You have studied basic electronics, I guess, I suppose. Okay, thankfully we got one answer. Sabari Maharaja. Thank you. Thank you. Thank you, people. Finally, we started getting some answer. Inductor. Okay. Inductor, capacitor, transformer. Okay, fine. Thank you. So now tell me for example for active. Any idea what active could be? See, very simple. Since we don't have the luxury of time, we'll dive into the session. So active is something which does not require power supply, right? It itself can create power supply, whereas passive, it depends on external power supply. Okay, likewise, in sensor, what we're going to see under active and passive is that active sensor, okay, this type of sensor, they require no external power. One best example that all of you would have seen is solar panel, right? You know what solar panel does, right? It converts sunlight or the sun's light energy into electrical energy, right? So the solar panel by itself, it does not recover energy. It just takes the sun's light and converts it into electricity, right? So it does not require any power supply, but it takes the natural physical quantity and converts it to an electrical energy. So this is an active sensor. It does not require power supply. You also, you would have seen this kind of solar panels in your calculators, in your scientific calculators, or the normal, even the normal calculators have small solar panels, right? What they do is that they absorb the light energy and convert them into electrical energy. We call those kind of sensors as active sensors. Then what is a passive sensor? Passive sensor require external power supply, right? Best example is camera sensor. Okay, the camera sensor requires a power, like sorry, they require external power, right? Okay, by the end of the session I'll start asking a few more questions. Now, analog and digital. Analog and digital, we can easily understand the basic and the difference between an analog and digital by looking at your wrist watches. Okay, if your wristwatch has uh, the dials, then we can call dials in sense it will be like moving on over a mechanical parts, which is like a analog, which are like analog watches, like you can see from this picture in the slide. Whereas digital, you'll have digital values. Okay, that is the basic difference. You can see that in your wristwatches. The smart watches that you have in the current day scenario is mostly digital watches because the output is in digital form. Whereas if the output is in analog form, we are that comes under analog sensor. Okay, so example for analog sensor is strain gauge. We have something called a strain gauge. I'll show you a working video of this particular sensor maybe in your next on the other class. What happens is that, I mean, what an analog sensor is that the output of this kind of sensor will be in analog form. Whereas if you take a digital sensor, the output of a digital sensor will be in digital form. Example is digital temperature sensors. Okay, so the small chip kind of thing that you see is the digital temperature sensor. It will it will sense the temperature and it will give only the digital values, right? Okay, so okay, now that we knew the basic difference, I mean like a basic classification of a sensor, it is like a must for us to know classification of transducer. Okay, transducer, I've already told you what a what a transducers are. Anyway, once again, kindly go through the slide. You will remember what we saw in our first session. Transducers are device that converts one form of energy to another, whereas sensor converts one form of energy to electrical. Okay, be very careful with that. Sensor converts any form of energy to only electrical. The output should be only electrical. Only then you can call it as a sensor. Whereas a transducer, the input can be any form as well as the output can also be of any form. That is why we can say that all sensors are transducers, but not all transducers are sensors. If you have attended the previous assignment in Kahoot, you would have seen this question and you might hope you would have answered correctly, right? Now we'll move to the next slide, which is classification of transducers. Now what you're going to see is the classification of transducers. In our like a few minutes earlier we saw classification of sensors. Now we are going to see about classification of transducers. Okay, so first one is based on transduction. We'll come to that. Next is primary, secondary, active and passive, what we have already seen, so we are not going to see it anymore. Analog and digital we have already seen, so not going to discuss it anymore. Now last one is transducer and inverse transducer. Okay, see, observe this slides, the forthcoming slides very keenly, because you are going to see this. Most of these are relevant in your day-to-day life. Okay, so I will be like asking you where you can see in real time. I hope you all will understand and try to answer. First one is based on transduction. Okay, transduction is the capacity to transduce or converting one form of energy to another form of energy. So based on transduction, we can classify transducers into resistive transducers, capacitive, and inductive. The best example for resistive transducer is we have something called as photoresistor. Again, if we were in class, I would have shown you a photoresistor. Unfortunately, we are not in class. Anyway, I will upload a video of simulating a photoresistor. What happens in photoresistor is that depending on the light's intensity, the resistance will decrease. Okay, that is what is photoresistor. So it is a resistor based on the principle of resistor. So you can call that as resistive sensor. Capacitive sensor is what actually we see in, we saw in our fingerprint. We saw capacitive fingerprint sensor, right? So that is an example for capacitive transducer. The inductive transducer is like there is something called as LVDT. So don't get confused. We'll have a separate session for LVDT. I'll explain it much deeper in that part. Okay, so inductance. Okay, what do you know about inductance? Can you tell me any example of inductance? One of the recent technology, even in our mobile phone, we have this inductance, the role of inductance. We have so many parts in that. Still, any idea how inductors are made? Come on, let's see. Actually, I love mobile phones and I love the sensors and all the electronic parts behind mobile phones. So most of the time, I'll try to give you uh, examples from mobile phones. Okay, it will also be very easy for you to understand too, because we all have mobile phones in our hand, right? So now, tell me, where what is an inductor? Can we make an inductor by ourselves? And where do you think is this inductance, or the principle of inductance is heavily used in mobile phones? Any idea? I'll give you 1 minute. Think about it. Mobile phone la, where are we using inductor? Mobile phone, we have capacitors, we have obviously we have lower resistors, capacitors, and inductors. No idea. Okay, since I don't get any reply, I think we'll say, see, the wireless charging. Wireless charging is actually based on inductance, mutual inductance. I don't know if you have studied this in your previous class. If you haven't studied, please go in it and see. Like, you see how wireless charging works. Then we have capacitors. These capacitors are wonderful things. As we know, capacitor does store energy, but why are we using batteries instead of capacitors? We all know capacitors store energy, right? But then why are we not using it for like in batteries? Actually, there is a good explanation. In certain cases, we are using capacitors like batteries. One best example is uh, we have something called as S Pen in for the mobiles. Samsung's Note series mobile phones, they along with the mobile phones, they provide something called the stylus. They have given it a name as S Pen, Samsung's pen. If you see, in the beginning, those Samsung pens, they actually use this kind of inductive sensors, but they could able to only write. But the present S Pen, you see, they can actually do more. Like, they don't only write, they can like control the mobile from wirelessly. Okay, so to control that, they use Bluetooth. There's something called as Bluetooth, BLE, Bluetooth lossless enable, something like that. And to power that, they will use capacitors. Okay, then inductors, as I told, uh, wireless charging, right? So since I couldn't show you more real-time images, I think we'll skip to the next slide.